Okay, when we take a look at angles and proofs, it's going to be very similar to what we looked at yesterday with angles or with segments and proofs. Okay, we want to look at the definition of congruence. Okay, the definition of congruence with angles is going to be changing from the degree measure of the angle to the actual angle name. Okay, so you're going to go from like the measure of angle A equaling the measure of angle B to angle AB congruent to angle B. Okay, this happens less with angles than it does with segments. Okay, but it will show up from time to time. And if you use the angle addition postulate, you'll have that pop up, because even down here with the angle addition, again, you have to use equations. Okay, so you have to be able to add the measures of the angles together, not the actual angles themselves. Okay, so it has to be in equations. Okay, the angle bisector definition, if you have a definition of angle bisector, it just says that the two angles are congruent. Transitive property, again, applies with congruent statements. Okay, if you have an equal sign there, it's going to be a substitution. Complementary angles, remember, add up to 90 degrees. You'll use the definition once in a while. Supplementary angles will probably show up more than complementary angles, but they add up to 180 degrees. The linear pair postulate, okay, doesn't tell you that the angles are add up to 180. It says they're supplementary. So you have to use the linear pair postulate to say that the angles are supplementary, and then you can use the definition of supplementary angles to state that the angles add up to 180 degrees. Okay, right angles with their congruence theorem, with the definition that the angles are 90 degrees, and the vertical angles theorem, remember you can always abbreviate with VAT. Okay, for VAT, vertical angles theorem. Okay, so we're going to move on here, and this is one that you saw maybe the other day. Okay, we've got a picture, okay, and we want to go again with our statements and our reasons. Okay, again, if it's helpful for you to fold your paper in half, you can do so, but it's not something that's 100% necessary. Okay, so on our statements, again, you're going to list your givens first. So we start with the fact that angle 1 is congruent to angle 3, because that is given to us in our problem. Okay, now, there's not much that we can do with that. We check and we notice we've got congruence here, we have congruence here, so we're going to not want to change it to an equation. So now you're stuck looking at your picture. And with angles, one thing that you can do is take a look at your angles and recognize that you have angles with where they're placed. Okay, angles 1 and 2 are what kind of angles? Okay, they're vertical angles. So angle 1 and angle 2 are going to be congruent. And again, you can use VAT for the vertical angles theorem. Okay, so know that that applies and that you can always work through with making sure that your angles are across from each other. The vertical angles are going to be equal. Now, because angles 1 and 3 are congruent and 1 and 2 are congruent, what should that tell you? Okay, that angles 2 and 3 are congruent. Okay, and again, because you're using all congruences, our reason for that needs to be what property? Okay, transitive. Good. So instead of using the substitution property, like you would if you had an equation, we're going to use the transitive property. Okay, and at any point, you guys obviously, since you're watching this on a computer, can pause the presentation if you need to take a little longer with the notes. All right, so our next one. Okay, we have angles 2 and 3 being supplementary. Okay, so again, we're going to list our statements column and our reasons column. Okay, and again, you're listing your givens first. So our first statement is an angle 2 and angle 3 are supplementary. Okay, and our reason is that's given. Now, as you go through this problem, there's going to be a couple ways that you can go about this. We're going to go the shortest route. Okay? And when we go with the shortest route, we take a look at our picture. There's not a whole lot that we can do, but we know that angles 1 and angle 2 are side by sides. So that creates a linear pair. And that means that angle 1 and angle 2 are supplementary, because linear pair postulate. Okay. Now, remember back on Friday, we talked about the congruent complements and congruent supplements theorem and how this could be a huge save. If you know that angle 2 and 3 are supplementary, then they have to add up to 180 degrees. And if angle 1 and 2 are supplementary, they have to add up to 180 degrees. So what we can go to right now is, because you know that angle 2 plus 3 equals 180 and 1 plus 2 equals 180, is that angle 1 is congruent to angle 3. And that is the congruent supplements theorem. Okay, you hardly will use that, but once in a while, it is a huge game changer because we don't have to write this huge long proof. And also with theorems, the word theorem, you can abbreviate that with THM. Okay. And then finally, the last proof, okay, that we've got, this is going to be one that's going to be very similar to what you'll see on the test. Okay, we again start with our statements and our reasons. Okay, this one is going to be a 5-step proof. And it has to be done in a certain way in order for things to be a little bit easier for you. You guys have seen this as we've gone through with the fill-in proofs. Okay, but we start with our statement that angle 1 is congruent to angle 4. Okay, because that's what's given to us. Now, we want to prove that angle 2 and 3 are congruent. Okay? Now, what that gives us is those two angles congruent to start. Okay, so we want to figure out what has to be congruent next. Okay, and you've got a couple different options here, and it's going to change maybe the order, and this is where the order is going to change versus the fill-ins. Okay, these two angles here at 1 and 2 have got to be the same because they're vertical angles. Okay, so we're going to go ahead and use the vertical angles theorem. Now my next step is going to be something that can be altered in order, but I'm going to teach it to you this way because I think it's going to make life a lot easier for you down the road. If we take a look at these two steps in combination, you'll notice that angle 4 and 1 are congruent and 2 and 1 are congruent. So our next step is going to be that angle 2 is congruent to angle 4. If I don't teach it to you this way, okay, and we're going to use the transitive property, it will make things a little bit of a mess at the end, and a lot of times students will miss the double transitive property if we don't go this route. So we want to go this route because angle 1 and 4 are congruent and 1 or 2 are congruent. That means our transitive property allows us to state that 2 and 4 are congruent. Okay, now, we're good with angle 2. We still need to get somehow that angle 3 is there. Okay, but you'll notice that angle 3 and 4 are also vertical angles. Okay, so we're going to go ahead and use the vertical angles theorem for that as well. Okay, we're not quite finished because we still want to show that 2 and 3 are congruent. But we notice that angle 2 is congruent to 4 and 3 is congruent to 4. So angle 2 is congruent to angle 3. The order in this problem does not necessarily matter, but the one thing that has to happen is you have to get the transitive property in there twice. You cannot use it across 4 angles. And if we don't put this step here as a transitive property, most times students are going to mess that up. Okay, they're going to forget to have one of the transitive properties at the end. Okay, at this point, the lesson is finished and you guys can get to work on your homework.